Hi Classpad.net users. Today I'm going to be focusing on triangles, specifically how to construct special triangles. So isosceles, equilateral, and a right triangle. So let's just pull up a geometry sticky here. And it's very easy on Classpad.net to just draw a triangle. So let's do that. We're going to draw a triangle. So here's my triangle ABC. But this is really what we would call any triangle. It can be any triangle that I want it to be. So I'm going to label this as my any triangle. And what do I mean by that? Well, right now, because nothing was constructed, it was all just drawn freehand, I can move any point and change. So it's now it's an obtuse triangle, and then I could try to make it right triangle. And we might even, let's just measure a couple things to help us. So let's measure this angle. I'm not going to measure all, I'm just going to measure one. Let's measure this side, and let's measure this side. Well, actually, let's measure all the sides. That might help. So I've measured all the sides. So right now, any triangle, scaling, and then if I said, okay, students, can you make your triangle be right? We could have them move it, but the nice thing about Classpad.net is we have this adjustment feature. So let's make it be a right triangle by adjusting it. So I'm going to take this angle B, and you'll notice under adjustment, I can now make that perpendicular. Boom, now I have a right triangle. But because this is just a drawing that I have adjusted, that right triangle is not locked in place. Right? So now it's back to being any triangle. I could do the same thing with pick two of the sides, and I could adjust them to be congruent, and now I have an isosceles triangle. And I could explore things like with it. I could measure the base angles and show that those are also congruent, but then if I move one of the vertices, it's no longer congruent, no longer isosceles. Same thing, I could select the whole triangle and adjust it to be regular. So now you'll notice that all three sides are congruent, so now it's an equilateral triangle. So very easy to draw a triangle, adjust it to be special triangles, but they don't stay or maintain their properties because this is really just a drawing that I've adjusted. So how do I construct those special triangles so that if I adjust the triangle, it always maintains the properties? Well, this requires you to use your prior knowledge, and circles come into play a lot when we're working with triangles. So let's get another geometry sticky up here, and this time we're going to focus on isosceles. So what do we know about isosceles? They have to have at least two congruent sides. So we are going to make one based on circles. So let's get a circle tool. Why am I using circles? Well, what do we know about circles? This is prior knowledge that students would have had. We know that if we construct the radius of this circle, if I construct two radii from the circle, right, so I've got two radii on this one circle. We know automatically, because of the definition of a circle, which says all the points on the circle are equidistant from the center, that this segment connecting the center to any point on the circle, they all have the same length, same distance. So AC and BA are congruent. I could measure them. I don't really need to. We're not going to. And if I change the size of the circle, they're still congruent, right? Because they're still connecting that center to the point equidistant on the circle. So this is two congruent sides, which is what I need for an isosceles triangle. So now all I have to do is I can get my polygon tool, or I could just get another segment, but I'm going to do polygon tool. And here is a triangle that I now know is isosceles because it's got two radii that are congruent. Therefore, even if I change this triangle, if I move the vertices, if I make it larger, if I make it larger, smaller, whatever, it is always going to be isosceles because I constructed it using properties of the radii to help me construct it. So I could even hide this circle if I don't want to see it anymore and I just want to focus on the triangle. Now I have this isosceles triangle that maintains being isosceles because of the way I constructed it. So notice the circle, which would come from a compass if you were doing this by hand, is used to help us get those congruent sides of that isosceles triangle. So let's think about the same thing if I want to do an equilateral triangle. So I'm going to pull up another geometry sticky here. This time we're going to focus on equilateral. So equilateral triangle. Equilateral. There we go. So again, all sides have to be congruent, right? So I still kind of want to work with that circle because I know segments in a circle that are the radius are always congruent. So I'm going to start with a circle, but I don't want, if I just use the radii from this one circle, that doesn't help me make all three, as we saw in this construction. So what I'm going to do is make a second circle. So here I've got the centers A, and the distance, the radius is AB. And now I'm going to use the center as B, and the same distance, AB, is a radius. But notice it's two different circles because I used a different center. But if I actually now construct a radius, or construct the segment AB, which we know is a radius in this circle A, and it's also a radius in this circle B, and since it's the same segment, it's the same length, so this radius AB is the same, right? So the radii, the distance, the radius of circle B and the radius of circle A are congruent, and even if I make the circles bigger, they're always going to have the same radius because of the way I constructed. That means any radius that I construct, so if I go into circle A, so center A, and construct a second radius that hits this intersection point, right, I know that AC, which is a radius in circle A, is the same length as AB because they're both in the same circle. And then if I construct a third radius with circle B, so it's going from the center back to circle the C, this is also the same distance because it's a radius. All the radii are equal. So basically, by having two intersecting circles that have the same radius, so two different center points with the same radius, I now end up with a triangle that is equilateral because all of these sides are radii of congruent similar circles, if we want to think of it that way. So I've now constructed an equilateral triangle. And again, you could hide these circles if you want to just focus on Right, so let's open another geometry and talk about the last special triangle I want to think about, which is the right triangle. Now, the right triangle doesn't have any special property except for the fact that it has a perpendicular. It has one of its angles is 90, right? Now, you could have a isosceles right triangle, so how would that impact up here? We would have to make sure that we made this radius right perpendicular to each other. But we're going to just focus on right triangle right now. So all I really need is a right angle. So to do that, I need a perpendicular. So I'm going to start with any side of the triangle, and again, that's just a segment. And I'm going to either put a perpendicular through A or a perpendicular through B. It doesn't matter which one, so let's just choose A and the segment, and we're going to construct that perpendicular. So now I want to put a point on that perpendicular so that I know that point is on so it stays on that line, right? So I know that anything connected to it, if I connect segment A to D, that's also perpendicular because it's just a segment on that perpendicular line, which means I don't need this line anymore. I needed the line to help me construct the right angle, but now I'm going to hide that. That's something I don't need. So now I just have this point, but remember the point is on that line. We just don't see the line anymore. But now I'm going to use my polygon tool and actually construct this triangle ABD. So A to D to B. So here's my triangle. And now if I verify, I'm going to measure this angle. It should be a right angle because I constructed it to be perpendicular. And it's a 90-degree angle. And so now I have a right triangle, and I can change the size of the right triangle, obviously, right? Because it's made of segments but what I can't change, because I constructed it to be always a right triangle, I can't change the measure of angle A here because I constructed this to be perpendicular. So that's a way to construct right triangles. Now it gets a little more complex if you think, okay, if I want an isosceles right triangle, how would I do that? So that would then require making a perpendicular somewhere here. And the easiest way is to make sure the radii that you use are perpendicular to each other. And obviously you can't have an equilateral right triangle because in equilateral all the angles are the same, so they have to be 60. So just a couple ways to think about triangles. So you've got your any triangle, your isosceles triangle, equilateral, but you're really using circles and that idea of congruent radii to show or to construct triangles that maintain those properties instead of drawings that when you adjust them work for a while, but then if you move vertex, because it's a drawing, it will go back to being any triangle. So have fun exploring that. It's a great investigation type of thing for students to do.